Hello dear friends, myself Devkar SC from Department of Chemistry, KVN9, Arts, Commerce and Science College, Nasi. Today we will emphasize on Classen's rearrangement. Classen's rearrangement is a rearrangement in which there is simultaneous breaking of carbon-oxygen bond and formation of carbon-carbon bond. The reactant of this reaction is allyl vinyl ether, which is converted into a gamma delta unsaturated carbonyl compound. This particular conversion is obtained merely on heating in presence of Lewis acid. It's a pericyclic reaction in which all the bond breaking and bond formation takes place in a concerted way. It's also called as sigmatropic shift since there is sigma bond shifting from one position to the another position. Now, in case of allyl vinyl ether, we can see its particular example. We have numbered the atoms as 1, 2, 3, 4, 5 and 6. It's just on mere heating, there is a bond formation between carbon number 1 and 6. So sigma bond is formed. Simultaneously, a pi bond is cleaved between carbon number 5 and 6, and a pi bond is formed at carbon number 4 and 5. There is a breaking of sigma bond between oxygen and carbon number 4, and simultaneously there is a pi bond formation between oxygen and carbon number 2 in order to to stabilize the positive charge generated at carbon number 2, and that's how you get a gamma delta unsaturated aldehyde. Let us go for another example of 3,3 sigmatropic shift, that is of allyl phenyl ether. And instead, over here, it's called as 3,3 sigmatropic shift. Why is it called as 3,3 sigmatropic shift? Because there's a bond formation and bond breaking takes place in this rearrangement, and they are with respect to third position. So at third position there is bond formation, and the bond breaking also takes place at the third position with respect to each other. Now let's take this aromatic allyl phenyl ether. Over here, there's a bond formation between carbon number 6 and 1. So this one position, and there's a bond breaking between carbon number 1 and 2. So that goes to form a pi bond between carbon number 2 and oxygen. Simultaneously, there is breaking of the bond between oxygen and carbon number 4 and forming a pi bond between carbon number 4 and 5. Now, this is the intermediate which is being formed, which is non-aromatic in nature. So, the allyl group is being substituted at ortho position, but the ring has been non-aromatic in nature. So finally, it immediately undergoes, it's an unstable intermediate, so it immediately undergoes tautomerism to form a phenol. And therefore, the final product we get is orthoallyl phenol. So this is a sigmatropic shape. Now let us take another example where you have where both the position of ortho substituents are totally blocked. Then how will the reaction get carried out? In this case, when both the ortho substituents are blocked, the rearrangement takes place just as the case of the previous reaction, that is 3,3 sigmatropic rearrangement takes place between at an ortho position. But since the ortho position already has another substituent, so there's a great steric interaction between the alkyl groups, and hence it will further undergo 3,3 sigmatropic shift before undergoing aromatization, leading to formation of an intermediate, and finally on shifting by 3,3 position, the allyl group gets substituted at para position, and finally there is aromatization of the ring takes place by tautomerism, leading to formation of para substituted phenol as the product. So this is your para Claisen's rearrangement. It leads to formation of tri-substituted phenols as the product. Thank you.